Trigonometry, Chapter 7, Applications of Trigonometry, Vectors, Section 1, Oblique Triangles and the Law of Sines, Video 9, The Law of Sines, Ambiguous Case, Example 2. This series is based on content from Pearson's Trigonometry 12th edition by Lial, Hornsby, Schneider, and Daniels. In the previous video, we solved an SSA law of sines problem and determined no such triangle exists. In this video, we solve another SSA law of sines problem. For example, in triangle LMN, suppose angle L equals 32.0 degrees, side L equals 60.0, and side N equals 100.0. Solve the triangle. Answer. The change in variables doesn't make it impossible to determine the number of solutions in advance. We would compare L with n sine of L instead of comparing A to B sine of A. Since n sine of L is about 52.99, we have n sine of L is less than side L, which is less than n, which means we should have two solutions. But you know what? Knowing that there are two solutions doesn't mean you found one of them. So I think we should just start the problem and determine that there's two solutions when the time is right. The time is when you do sine inverse. Let me lay that out there right now. The time to figure out 0, 1, or 2 solutions is when you do sine inverse, and you'll see an example of that here in just a second. Now we're going to set up the law of sines, and with the given information, we would set up sine of L over L, so sine of 32.0 degrees over 60.0, is sine of N over N, since we know side N, so sine of N over 100.0. Let's start solving for N. We would multiply both sides by 100 and then take sine inverse, so let's go right to it. N is sine inverse of 100.0 times sine of 32 degrees over 60.0, which is approximately 62.0 degrees. Now, please embed the following in your head. When you're using the law of sines and you get an angle, you're solving for an angle, you must also consider its supplement. This is from an equation solving perspective. It's a cast thing. As an equation, sine equal to a positive number always has solutions in quadrants 1 and 2, and they're supplements of each other. So when we use inverse sine to solve for an angle in a triangle, we must also consider its supplement, which in this case is 118.0 degrees. So we're going to proceed down two paths now. At this juncture, we have two possible outcomes, depending on which value for angle N we continue with. We must pursue both and see if the results are reasonable. Henceforth, we will designate our values as N1 equals 62.0 degrees and N2 equals 118.0 degrees. And at the end, we use Desmos to verify that both of these solutions are correct. Now, solution number 1 with our initial value of angle N is 62.0 degrees. Since we now have two of our angles, L and N, we can find the third angle pretty straightforward. M1, we can continue using subscripts from this point forward, is simply 180 minus the angle we were given, minus the angle we just calculated, which is 86.0 degrees. So what all do we have now? We have two angles and two sides. Excuse me. We have three angles and two sides. Now we just got to find the third side. Now that we have angle M, our first angle M is 86.0 degrees, we can use the law of sines to find the remaining side. So let's set up sine of 86.0 degrees, angle M, over M1 equals sine of 32.0 degrees over 60, what we were given. Now, if you're wondering why didn't I use sine of 62 degrees over 100, that's because I like to not use rounded off values whenever possible. The angle for 60.2.0 was rounded, and you may argue, yeah, but we use that to get the 86.0 as well, and you're right. The 86.0 is rounded, but we had to use that to find side M. Angle L was given to us and not rounded, so always try to use given information as much as possible. Try not to use rounded information in intermediate calculations. It prevents discrepancies in final results. So anyway, we solve this and we get M1, side M1 is 60 sine of 86.0 degrees over sine of 32.0 degrees, which is 112.9, which means our first complete solution, all sides and angles, is summarized here. When you solve a triangle, you have six pieces of information, three angles, three sides. They'll give you three, you find the other three. But be careful. This was assuming the angle N was 62.0 degrees. It could also be 118.0 degrees. When you use inverse sine to find an angle using the law of sines, you must always consider its supplement. So following the same path, if the second value then was 118.0 degrees, then our second angle M was 30.0 degrees. And then we could set up the law of sines again, but this time use 30.0 degrees. And we'll get M2 is about 56.6, giving us our second complete solution. Now, I know I went through that pretty quickly, but it's fairly straightforward at this point. This is kind of showing you the path that you would take. Now, we're going to take a quick look at Desmos to see both solutions. Actually, this video has already gone a little bit longer than I wanted, but you've seen the video before where the pivoting side is long enough to reach the bottom, but you can pivot left and right and make two triangles. I do want to show you a non-Desmos way to verify the validity of the solutions. In any triangle, the shortest side is always opposite the smallest angle, the longest side is always opposite the largest angle, and it's a good idea to spot check this in each solution. So in each solution, you'll notice that the shortest side, which over here was 60, is opposite the smallest angle, which was 32. In our second solution, the shortest side, 56.6, is opposite the smallest angle, 30.0 degrees. And you should also check the longest ones. Longest side is opposite the largest angle in both solutions. Now this does force the middle side to be opposite the middle angle, but if you check the smallest and the largest, then the middle will fall into place. All right, checking these can help spot errors in solutions because if you get to the end and the shortest side is not opposite the smallest angle, or the longest side is not opposite the largest angle, you know a mistake was made. All right, now you try. Pause the video and try the following. Solve triangle ABC if side A is 6.5, side B is 7.5, and angle A is 50 degrees. There will be two solutions, by the way. All right, if you haven't paused the video yet and tried it, here's your fair warning. Solution in 3, 2, and 1. If we set up the law of sines, we get sine of 50 over 6.5 equals sine of B over 7.5. Solving gives us a first angle of B of 62.1 or its supplement of 117.9. So for the first solution, where angle B is 62.1, we get angle C is 67.9 degrees, and then we set up the law of sines to get side C is 7.9. But if we use the second angle B of 117.9, then we get the second angle C is 12.1, set up the law of sines, and we get the second side C is 1.8. I don't think I've got these summarized. I don't, but there's two sets of solutions.